Okay, here's question 3. It's a full-page question based on the graph y equals x cos 2x, which they helpfully sketch for you. dy by dx is the first thing we need to find. So you need to look carefully at this, decide which rule you need, and you need to recognise that it is a, well, I hope you can recognise for yourself, this is a product, so make sure you use the product rule. Then on to part B. The point on the curve A, they helpfully tell us, is a stationary point. Okay, so our starting point is a stationary point. We've got dy by dx. You should remember from core 1 that at a stationary point, dy by dx equals a particular thing, naught. So write that down first, and then take your answer to A, and you need to show, starting from dy by dx, this is a show that question, so this is your end point. So you need to start with your dy by dx expression equaling naught. You need to rearrange it into here. X's have changed into alphas because the particular x coordinate of the point A is alpha. If you simply rearrange this equation equal to naught using x's, and then as your last step change x to alpha, because at the point A that's where the gradient does equal naught, that will be fine. So don't get in a twist over when x changes to alpha. You can do that at almost any stage, but you do need to carefully take your expression for dy by dx equal to naught and do careful stages in your algebra to get down to this expression. Obviously you need to have had the right dy by dx for that. However, from this point onwards, here's a re-entry point, so if you couldn't do any of that, this method of showing that alpha is between two particular values, you've got something that equals naught, so if f of x has to equal naught, and you want to show the value of alpha is between two other ones, you put those two into f of x, so you work out f of two values. You notice something about the two answers you get, make sure your calculator is in the correct mode, and you write the standard sentence from your notes to cash in for the 2 marks. You need to explain it properly and end up with a statement given in the question that alpha is between 0.4 and 0.5. Okay, another re-entry point. Your starting point for this is this equation. We simply need to rearrange it into that without cheating. So just take it steady, one step of algebra at a time. Think very carefully about what you're doing to both sides of the question, and don't try and fudge it. It's just 1 mark, but it's worth doing accurately. Another re-entry point, easiest part of the question so far. They give us a formula, they give us a starting value. All we've got to do is put the value into the formula, work the method through a couple of times, being very clear about the method at least the first time. Don't round off any answers until you get to x3, in which case you need to round it off to 2 significant figures as you're told to. And then finally, another re-entry point. The part C has nothing to do with the rest of the question. We just have to do an integration by parts with limits on. So integration by parts, you need a u. Remember, on this method you don't choose a v, you choose a v dashed. So we've got a u and a v dash. Decide which one is u using the late rule. Set up your u dashed, set up your v, standard method for integration by parts. You can ignore the limits until you've got the full answer, if you like. So once you've done the full answer, don't put the plus c on the end. Have your square brackets with your limits on. Substitute both in. Don't ignore the limit of naught. That very possibly won't give you an answer of naught when you substitute it in. And this should be 5 marks for a pretty standard application of integration by parts. So if the first half of the question isn't going too well, make sure you cash in on part C.